Hello friends, in my previous video I had completed practice set 2.1, 2.3. Now in this video I will explain all the examples from the practice set 2.3 and all solved examples. Okay, now let us start. Root of a positive rational number. We know that if x square is equals to 2, then x is equals to root 2 or x is equals to minus root 2, where root 2 and the minus root 2 are irrational numbers. We know that cubic root of 7, fourth root of 8, these numbers are irrational numbers too. If n is a positive integer and x raised to n is equals to a, then x is nth root of a. That is, x is equals to nth root of a. This root may be rational or irrational. For example, 2 raised to 5 is equals to 32. Therefore, 2 is fifth root of 32. But if x raised to 5 is equals to 2, then x is equals to fifth root of 2, which is an irrational number. Now surds. We know that 5 is a rational number, but root of 5 is not rational. Square root or cube root of any real number is either a rational or irrational number. Similarly, nth root of any number is either rational or irrational. Now, if n is an integer greater than 1 and if a is positive real number and nth root of a is x, then it is written as x raised to n is equals to a or nth root of a is equals to x. If a is positive rational number and n root of a is x and x is irrational number, then x is called a surd. Next, in a surd nth root of a, the symbol that is called the radical sign. N is the order of surd and a is called radicand. Now first example here, let a is equals to 7, n is equals to 3. Then cubic root of 7 is a surd because cubic root of 7 is an irrational number. Next, let a is equals to 27, n is equals to 3. Then cubic root of 27 is not a surd because the cubic root of 27 is equals to 3 and 3 is a rational number. It is not the irrational and hence cubic root of 27 is not a surd. Okay, here the cubic root of 27 is the 3 is not an irrational number. Therefore, it is not surd. Now next, cubic root of 8 is a surd or not. Now here cubic root of 8 is equals to p. If you take cube on both sides, that is a p raised to 3. Okay, and the cube of cubic root of 8 is equals to 8. Therefore, you will get here p raised to 3 is equals to 8. Cube of which number is 8? Okay, that is the cube of 2 is 8. We know 2 is a cube root of 8 or cube of 2 is 8. Therefore, cube root of 8 is not a surd. If you find the cube root of 8, that is equals to 2 and 2 is a rational numbers and hence this is not surd. Next, whether fourth root of 8 is a surd or not. Here a is equals to 8 order of surd n is equals to 4. But fourth root of 8 is not a rational number, and hence fourth root of 8 is an irrational number, and therefore fourth root of 8 is a surd. This year we are going to study surds of order 2 only, means root 3, root 7, root of 42, etc. The surd of order 2 is called quadratic surd. Now, simplest form of a surd. First, root of 48. Root of 48 can be written as 16 into 3. Now, separate it. That is the root of 16 into root of 3. What is the root of 16? Is 4. Therefore, 4 root 3. And this is the simplest form of the surd. Root of 98. Root of 98 can be written as root of 49 into 2. Separate it. Root of 49 into root 2. Root of 49 is 7. 7 root 2. Now root 2, root 3, root 5. These type of surds are in the simplest form which cannot be simplified further. Similar or like surds. Now see this here, root 2 minus 3 root 2, 4 by 5 root 2 are some like surds. If P and Q are rational numbers, then P into root A, Q into root A are called like surds. Two surds are said to be like surds if their order is equal and radicands are equal. Now here the radicand is A and order is 2, and therefore these two surds are equal. Also, all these surds are equal because their radicand is 2 and the order of surd is here 2, order of surd is 2, order of surd is 2, and therefore these surds are like surds. Root of 45 and root of 80 are the surds of order 2. So, their order is equal but radicands are not same. Here 45 and here is 80. Order is same but radicand are different. Are these like surds? Let us simplify it as follows. Now root of 45 can be written as 9 into 5. Separate it, root of 9 into root of 5. What is the root of 9? Is 3. 3 root 5. And what about the root of 80? Root of 80 can be written as 16 into 5. And what about the root of 16? Is a 4. 4 root 5. Now the order of these two surds are same. Their radicands are also equal and these two surds are like surds after simplification. Therefore, 3 root 5 and 4 root 5 are similar or like surds, means root of 45 and the root of 80 are similar surds. Remember this. In the simplest form of the surds, if order of the surds and radicands are equal, then the surds are similar or like surds. Now next, comparison of surds. Let A and B are two positive real numbers, and if A is less than B, then if you multiply to this inequality by A, then A into A is less than B into A, means what, A square is less than AB. Okay, this is the first one. And again, if you multiply this inequality by B, then AB is less than B square. This is the second one. Therefore, if A is less than B, then you will get A square is less than B square from 1 and 2. On contrary, if A square is less than B square, then you will have these possibilities, that is A is equals to B, A is greater than B, and A is less than B. We will verify these possibilities. Okay, if A is equals to B, then what you will get here? A square is equals to B square, but this is not possible. And if A is greater than B, then A square is greater than B square, but again this is not possible. and therefore the correct possibility is if a square is less than b square, then a is less than b is correct one. Hence, if a is less than b, then a square is less than b square. And hence, we will say that here a and b both are real numbers. So, they may be rational numbers or surds by using above these properties. Now next, let us compare the surds. First example, 6 root 2, 5 root 5. Now here, this 6 can be written as root of 36 into root 2, and 5 root 5 can be written as, this 5 can be written as root of 25 into root 5. Next, here a root of 36 into root 2, it means that root of 36 into 2, then you will have here a root of 72. Root of 25 into root 5 is written as root of 25 into 5. Okay. But here 75 is less than 125. Here the order of these two surds are equal. But the right hand 125 is greater than 72. That is 72 is less than 125. And hence 6 root 2 is less than 5 root 5. Now next. 8 root 3 and root of 192. Now again, here this 8 can be written as root of 64 into root 3 and root of 192 as it is. Root of 64 into root 3 means what? Root of 64 into 3. Then you will get here root of 192 and here root of 192. Now the radicands are same, order is also same. 192 is equals to 192 and hence 8 root 3 is equals to root of 192. These two surds are equal. Now next, 7 root 2 and 5 root 3. Again here, 7 means what? Root of 49 into root 2 and 5 means what? Root of 25 into root 3. Now again, root of 49 into root 2 means what? Root of 49 into 2. Then you will get here root of 98 and root of 25 into root 3 means what? Root of 25 into 3, that is the root of 75. Now here the order of these surds are same and here 98 is greater than 75 and hence 7 root 2 is greater than 5 root 3. Now operations on like surds. Mathematical operations like addition, subtraction, multiplication and division can be done on like surds. First example, simplify 7 root 3 plus 29 root 3. These are the like surds. If we take root 3 as a common, then in bracket you will get here 7 plus 29. If we add it, then you will get here 36 root 3. Okay. Next example, simplify 7 root 3 minus 29 root 3. Okay, take root 3 as a common, then in bracket you will get here 7 minus 29, that is minus into root 3, that is equals to minus 22 root 3. Now use brain power, your brain power, that is root of 9 plus 16 question mark is equals to root 9 plus root 16. Are they equal? Okay, now we'll verify here. Now first, root of 9 plus 16 is question mark root of 9 plus root of 16. Now what is the root of 9 plus 16? That is the root of 25. Root of 9 is 3, root of 16 is 4. If you add these two, then you will get here 7 and root of 25 is 5. Now here 5 is not equals to 7 and hence these two are not equal. Next, root of 100 plus 36 question mark is equals to root of 100 plus root of 36. Now what is the root of 100 plus 36? That is the root of 136 and root of 100 is 10 plus root of 36 is 6. If you add it, then you will get here a root of 136 and here 10 plus 6, that is equals to 16. Okay. And again, these two are not equal. They are not equal. Here root of 16 can be written as in root of 256. Now the order is same. Then the again the root of 256 is a greater than root of 136. Okay. But here we have asked here whether these are equal. Therefore, they are not equal. Okay. Now next. Example number 3. Simplify 13 root 8 plus 1 upon 2 root of 8 minus 5 root of 8. Now see this here. 13 root 8 plus 1 upon 2 root 8 minus 5 root 8. Now take root 8 as a common. Then in bracket you will get here 13 plus 1 upon 2 minus 5. Again simplification by the LCM. Multiplied to this 13 to the numerator and denominator by 2. 13 into 2 you will get a 26 upon 2 plus 1 upon 2. Again multiply this 5 upon 1 by to the numerator and denominator by 2. Then to the numerator you will get a 10 upon 2, and as their base are equal, therefore 26 plus 1 minus 10 upon 2 into root 8. Okay. Now the next 17 upon 2 into root 8. Again, this root 8 can be written as root of 4 into 2. The root of 4 is 2. Therefore, 17 upon 2 into root of 4 is 2. And here, into root 2. Again, simplification. This 2 will get cancelled. And then you will get here 17 root 2. Example number 4. Simplify 8 root 5 plus root of 20 minus root of 125. Now 8 root 5 plus root of 20 minus root of 125, as this is the prime number, keep it as it is. 8 root 5, 20 can be written as 4 into 5. Okay, square root of 4 is 2, and root of 125 can be written as 25 into 5. Therefore 8 root 5 as it is. Root of 4 is 2, therefore 2 root 5, and root of 25 is a 5 root 5. Now here these are the like surds. Take root 5 as a common. 8 plus 2 minus 5, that is a 10 minus 5 into root 5. Then you will get here 5 root 5. Multiply this surd root of 7 into root of 42. Now here the order of these two surds are same. Therefore we will multiply here. That is the root of 7 into 42. Their multiplication is a 7. 42 can be written as 7 into 6. Okay. Now again here is a 7 into 7 means what? 49. The root of 49 is 7. Therefore it is written as 7 root 6. Okay. And this is an irrational number. Next, example number 6. Divide these surds. Root of 125 divided by root 5. Now the solution, root of 125 upon root 5. Again, both the surds have the same order. We can write in root of 125 upon 5. Then you will get a root of 25, and that is equals to 5. 5 is a rational number. Next, root of 50 into root of 18. Root of 50 can be written as 25 into 2 into root of 18 can be written as 9 into 2. Root of 25 is a 5 root 2 into root of 9 is a 3 root 2. Root 2 into root 2, then you will get here 2. 5 into 3, 15. 15 into 2, you will get here 30. Okay. Now next. Rationalization of surds. If the product of two surds is a rational number, each surd is called a rationalizing factor of other surd. Now, first example, if surd root 2 is multiplied by root 2, then what you will get here? Root 2 into root 2, the order of these two surds are same. Therefore, we can write here root of 2 into 2. 2 into 2 is 4 and root of 4 is 2. Okay, therefore rationalizing factor of root 2 is root 2. Therefore, a root of 4 is equals to 2 is a rational number. Root 2 is a rationalizing factor of root 2. Example number 2. Multiplied root 2 into root 8. Now here, see this here. The order of these two surds are again same. Therefore, root of 2 into 8 means what? 2 into 8 is a 16. Therefore, root 2 into root 8 is equals to root of 16. And what is the root of 16? That is equals to 4. Is a rational number. Root 2 is rationalizing factor of root 8. Similarly, 8 root 2 is also a rationalizing factor of root 2 because 2 into 8 root 2 is equals to 8 root 2 into root 2, and this is nothing but 8 into 2, and that is equals to 16. Okay, because root 2 into root 2 you will get here 2. 2 into 8 16. Now remember this. Rationalizing factor of a given surd is not unique. If a surd is rationalizing factor of a given surd, then a surd obtained by multiplying it with any non-zero rational number is also a rationalizing factor of the given surd. Now example number 3, find the rationalizing factor of root of 27. Now see this here, root of 27 can be written as root of 9 into 3, and root of 9 is 3, 3 root 3. Now again multiply this 3 root 3 by root 3, then root 3 into root 3, you will get here 3. 3 into 3, 9 is a rational number, and hence the root 3 is a rationalizing factor of root of 27. Okay, now root of 27 can be written as 3 into root 3 means 3 into root 3 into 3 into root 3. Again 3 into 3, 9. Root 3 into root 3 is 3. 9 into 3, 27. And hence 3 root 3 is also rationalizing factor of root of 27. In the same way, 4 root 3, 7 root 3 are also rationalizing factor of root of 27. Out of all these, root 3 is the simplest rationalizing factor. Next example, rationalize the denominator of 1 upon root 5. 1 upon root 5, therefore here we multiplied to the numerator and the denominator by root 5. Now again here root 5 into root 5, you will get here 5. 1 into root 5, here is a 5. That is 5 upon root 5. Now the denominator is a rationalized. There is a number of 5 and 5 is a rational number. Okay. Now next, rationalize the denominator of 3 upon 2 root 7. Okay. Now here we'll multiply numerator and the denominator by root of 7. To the denominator we have irrational number is root 7, and hence we will multiply numerator and the denominator by root of 7 to the numerator and the denominator. Okay. Now here root 7 into root 7, you will get here 7. 7 into these two. Okay. Next to the numerator, 3 into root 7. Then you will get here 3 root 7. 2 into 7 is 14. And hence, denominator is a rationalized. Okay. Now remember this. We can make use of rationalizing factor to rationalize the denominator. It is easy to use the numbers with rational denominator. That is why we rationalize it. Now practice set 2.3. First example, state the order of the surds given below. First, cubic root of 7, 5 into root of 12, fourth root of 10, root of 39, cubic root of 18. Now answer. The order of the given surds are First, cubic root of 7, the order of the given surd is 3. 5 root 12, the order of this surd is 2. Fourth root of 10, the order of the given surd is 4. Root of 39, the order of given surd is 2. Cubic root of 18, the order of this given surd is 3. Okay. Now next, state which of the following are surd. Justify. Okay, these are the examples. Now we'll take one by one. First example, cubic root of 51. Now here, cubic root of 51 is surd. Why it is surd? Justification. Because the radicand is positive rational number. 51 is a positive rational number. The order of surd, n, the order is 3, which is greater than 1. And the cubic root of 51 is an irrational number. And hence, cubic root of 51 is surd. Next, fourth root of 16. Fourth root of 16 is not surd. Justification. The radicand is positive rational number. Here, root of 16 is a positive rational. The order of the surd, n is greater than 1, but fourth root of 16, that is 16 raised to 1 by 4, that is a 2 raised to 4 bracket raised to 1 by 4, that is equals to 2, which is not an irrational number, and therefore fourth root of 16 is not surd. Now next, fifth root of 81. Fifth root of 81 is a surd. Now again justification. The radicand is a positive rational number. The order of the surd, n is greater than 1. Fifth root of 81 is an irrational number, and hence fifth root of 81 is surd. Now next, answer is already there. Root of 256 is not surd because the root of 256 is 16. Now how it is? Justification. Root of 256 is not surd. Justification. The radicand is positive rational number. The order of surd, n is greater than 1. The order is 2. But root of 256 is equals to 256 raised to 1 upon 2 means what? 16 raised to 2 bracket raised to 1 upon 2, and after simplification, square and its root get cancelled. You will get here 16, which is not rational, irrational, and hence root of 56 is not surd. Next example, cubic root of 64. Cubic root of 64 is not surd. Again justification. The radicand is positive rational number. The order of surd, n is greater than 1. But cubic root of 64 is equals to 64 raised to 1 by 3. 64 means what? 4 raised to 3. Bracket is to 1 by 3. Now these 3 get cancelled. Okay. Therefore, you will get here 4, which is not irrational number. And hence, cubic, cubic root of cubic root of 64 is not surd. Now next, already answer is there. That is the root of 22 upon 7 is the surd. Okay. Justification. Because the radicand is positive rational number, the order of surd, n is greater than 1, it is 2. Order is 2. Question number 3. Classify the given pair of surds into like surds and unlike surds. First, root of 52 and 5 root 13. Next, root of 68, 5 root 3. 4 root of 18 and 7 root 2. 19 root of 12 and 6 root 3. 5 root of 22 and 7 root of 33. 5 root 5 and root of 75. Okay. Now, first example, root of 52 and 5 root 13. 52 can be written as root of 4 into 13, root of 4 into root 13, root of 4 is 2, then you will get here 2 root of 13. Now, root of 52 is equals to 5 root 13 and this 5 root 13, these are like surds. Next example, root of 68 and 5 root 3. Root of 68 can be written as root of 4 into 17, root of 4 into root of 17, root of 4 means 2, 2 root of 17 and 2 root of 17 and 5 root of 3 have their order equal but radicands are different. Hence, root of 68 that's equals to 2 root of 17 and 5 root 3 are unlike surds. Next example, 4 root of 18 and 7 root 2. Now we'll simplify first. 4 root of 18. Now 4 root of 18 can be written as 4 into root of 18 means what? 9 into 2. Root of 9 into root 2 into 4. And what about the root of 9? Root of 9 is 3. That is a 4 into 3 into root 2. 4 into 3 is a 12. 12 root 2. Okay. And here 4 root of 18 that's equals to 12 root 2 and 7 root 2 are like surds. Next example, 19 root of 12 and 6 root 3. Now we'll simplify the first one. 19 root 12 is equals to 19 into root of 4 into 3. Separate it, that is a 19 into root 4 into root 3. Okay, root of 4 is 2. Therefore, 19 into 2 into root 3. 19 into 2 means what? 38 into root 3. Okay, again 19 root 12 means what? 38 into root 3 and 6 root 3. Again, these are like surds. Next, 5 root of 22 and 7 root of 33. It's clear that these are unlike surds. 5 root of 22 and 7 root of 33 have their order equal, but the radicands are different. Therefore, 5 root of 22 and 7 root of 33 are unlike surds. Next, 5 root 5 and root of 75. Now we'll simplify the root of 75 first. Root of 75 is equals to root of 25 into 3. Root of 25 into root 3. Root of 25 is 5. Therefore, 5 root 3. Okay. And therefore, 5 root 5 and 5 root 3 have order equal, but radicands are different. Okay. And therefore, 5 root 5 and 5 root 3 are unlike surds. 5 root 3 means what? Root of 75. Now next, question number 4. Simplify the following surds. Now the first example, root of 27, root 50, root of 250, root of 112, root of 168. Now answer, root of 27 can be written as 9 into 3, root of 9 into root 3, root of 9 is 3. Therefore, you will get here 3 root 3 in simplified form. Next, root of 50. Root of 50 can be written as root of 25 into 2. Root of 25 into root 2. Root of 25 is 5. 5 root 2. Next, root of 250. Root of 250 can be written as root of 25 into 10. Root of 25 into root 10. And root of 25 is 5. 5 root 10. Next, a root of 112 can be written as root of 16 into 7, root of 16 into root 7, root of 16 is 4, 4 root 7. Root of 168 is equals to root of 4 into 42, root of 4 is 2 into root of 42. Okay. Now next, now compare the following pairs of surds. First, 7 root 2, 5 root 3. Now 7 root 2 can be written as 7 means what? Root of 49 into root 2. Again, root of 49 into root 2. Both of them have same order. We can write root of 49 into 2 and that will become root of 98. Next, 5 root 3. Again 5 can be written as root of 25 into root 3. Both of them have the same order. Therefore, root of 25 into 3 means what? Root of 75. Now here 98 is greater than 75 and hence root of 98 is greater than root of 75. But root of 98 means what? 7 root 2 and hence 7 root 2 is greater than 5 root 3. Now next, root of 247 and root of 274. Now here the order of the surds is the same, which is 2, and 247 is less than 274 and hence a root of 247 is less than a root of 274. Next, 2 root 7 and root of 28. Now 2 root 7 can be written as 2 can be written as root of 4 into root 7 as it is. 2 can be written as root of 4 into root 7. Again, root 4 into root 7 means what? Root of 4 into 7. 4 into 7 means what? 28. And hence root of 4 into root 7 means what? Root of 28. And here 2 root 7 means what? A root of 28 and here is again root of 28. Both are equal and hence these two surds are equal. That is a 2 root 7 is equals to root of 28. 5 root 5 and 7 root 2. Now again 5 root 5 can be written as, this 5 can be written as root of 25 into root 5. Root of 25, now again 5 can be written as root of 25 into this root 5. Again root of 25 into 5, then you will get here root of 125. 25 into 5 is 125 and hence we have here root of 125, this first one. Second, 7 root 2. Now here 7 can be written as root of 49 into this root 2. Again root of 49 into 2 means what? Root of 98. Now here 125 is greater than 98, but 1 root of 125 means what? 5 root 5 and hence 5 root 5 is greater than 7 root 2. Now next, 4 root of 42, 9 root 2. Again 4 root of 42 can be written as 4 means what? Root of 16 into root of this 42. Again in root of 16 into 42, then you will get here root of 672. 9 root 2 means what? 9 means what? Root of 81 into root 2. Again root of 81 into 2 means what? Root of 162. And here again root of 672 is greater than root of 162 as 672 is greater than 162 and hence 4 root of 42 is greater than 9 root 2 and this is the answer. Next, 5 root 3 and 9. Now 5 root 3 can be written as 5 can be written as root of 25 into this root 3. Again, root of 25 into root 3 means what? Root of 25 into 3 means what? Root of 75. 25 into 3 means what? 75. Therefore, you will get here a root of 75. Now next, this 9 can be written as root of 81. Now here 5 root 3 is equals to root of 75 is less than 9. 9 means what? Root of 81. Okay, it means that root of 75 is less than root of 81 and hence 75 is less than 81, that is 5 root 3 is less than 9. Next, 7 2 root 5. Again, this 7 can be written as root of 49 and root 5 can be written as, this 2 can be written as root of 4 into this root 5. Root of 4 into root 5 means what? Root of 4 into 5. 4 into 5 means what? 20. That is the root of 20. Now which is greater? That is the root of 49 is greater than root 20. And hence 49 is greater than 20. That is root of 49 is greater than root of 20. But 49 is for 7 and root of 20 is for 2 root 5. And hence 7 is greater than 2 root 5. Next example. Now question number 6. Simplify. 5 root 3 plus 8 root 3. Therefore 5 root 3 plus 8 root 3 and that is equals to in bracket 5 plus 8 into root 3 equals to 13 root 3 and hence the answer is 13 root 3. Next example. 9 root 5 minus 4 root 5 plus root of 125. Now here 9 root 5 as it is minus 4 root 5 and root of 125 can be written as 25 into 5. 9 root 5 minus 4 root 5. Root of 25 is 5. That is a 5 root 5. Take root 5 as a common. Then in bracket you will get here 9 minus 4 plus 5. 9 plus 5 that is 14. 14 minus 4. Then you will get here 10. 10 root of 5. Therefore simplified form is 10 root 5. Next example. 7 root of 48 minus root of 27 minus root 3. Now root of 48 can be written as, that is a 7 into root of 48 means what? 16 into 3. Root of 27 means what? 9 into 3 minus root 3. Again separate this, that is a 7 root of 16 into root 3. Root of 9 into root 3 minus root 3. Root of 16 means what? 4 root 3, that is 7 into 4 root 3. Next, root of 9 means what? 3. 3 root 3 minus root 3. Next, 28 root 3 minus 3 root 3 minus root 3. Okay. Next, take root 3 as a common. Then in bracket you will get here 28 minus 3 minus 1. Bracket complete into root 3. And hence, you will get here 24 root 3. That is a 28 minus 3 means what? 25 minus 1. Again, it will become 24. Okay. Then hence the answer is 24 root 3. Next example. 7 minus 3 by 5 root 7 plus 2 root 7. Take root 7 as a common. Then in bracket you will get here 1 minus 3 by 5 plus 2. Next simplification. Now here multiplied numerator and the denominator of this 1. 1 means what? 1 by 1 multiplied by 5. Then you will get here 5 by 5. Here minus 3 by 5. Again multiplied this 2 by 1 is by 5. Then you will get here 10 upon 5. And after simplification, you will get their common base which is 5. That is 5 minus 3 plus 10 upon 5 into root 7. Okay. That is a 5 plus 10. 15 minus 3, that is a 12. Hence you will get here 12 upon 5 into root 7. And hence the answer is 12 by 5 into root 7. Next, multiply and write the answer in the simplest form. First example, 3 root of 12 into root of 18. 3 root of 12 into root of 18. Now this 3 as it is. Root of 12 can be written as root of 4 into 3 into root of 18 can be written as root of 9 into 2. Next, root of 4 means what? 2, 2 root 3, and root of 9 means what? 3 root 2. Okay, next multiplication, 3 into 2 into 3, root 3 into root 2, 3 into 2, that is a 6, 6 into 3, 18, 18, root 3 into root 2, root 3 into root 2 means what? Root of 3 into 2, that is a root of 6, and that's equals to 18 root 6. Next example, 3 root 12 into 7 root of 15. Now again 3 root 12 into 7 root of 15, that is a 3. Root of 12 can be written as root of 4 into 3 plus into 7 into root of 15 means what? 3 into 5. Okay. Next, root of 4 is 2, therefore 3 into 2 into root 3 into root 7 into again root of 3 into 5 means what? Root 3 into root 5. Next simplification, that is a 3 into 2 into 7. Next, root 3 into root 3 into root 5. Next again, 3 into 2 into 7. This root 3 into root 3, it makes 3 into root 5. And next multiplication is easy. That is a 3 into 2 into 7 into 3 means what? 126 into root 5. That is 126 root 5. Next, 3 root of 8 into root 5. Now 3 root of 8 into root 5. 3 root of 8 can be written as root of 4 into 2 into root 5. Root of 4 into root 2 into root 5. Root of 4 means what? 2. That is a 3 into 2 into root of 2 into 5. That is a 3 into 2 means what? 6. Root of 2 into 5 means what? Root of 10. And hence the simplified form is a 6 root 10. Next, multiply and write the answer in the again simplest form. Next, 5 root 8 into 2 root 8. It's very easy. 5 root 8 into 2 root 8. Now here 5 into 2 root 8 into root 8. Root 8 into root 8 means what? 8. Okay. 5 into 2 10. Root 8 into root 8 is 10. 10 into 8, that's you will get 80. And hence answer is 80. Now next question. Divide and write the answer in the simplest form. First example, root of 98 divided by root 2. Now solution. Root of 98 upon root 2 can be written as root of 98 upon 2. 98 upon 2 means what? 49. That is the root of 49 and that's equals to 7. And this is the answer. Next, root of 125 divided by root 50. Again root of 125 upon 50. Then root 125 can be written as 25 into 5 and 50 can be written as 25 into 2. Okay, this 25 get cancelled and then you will get here root of 5 by 2 and hence the answer is root of 5 by 2. Next example, root of 54 divided by root of 27. Okay, that is the root of 54 upon root of 27. Next, root of 54 upon root of 27. 54 can be written as 2 into 27. 27 get cancelled and hence you will get here a root 2. Okay, and it is a simplified form. Next example, root of 310 divided by root 5. Again, it can be written as root of 310 upon 5. That is 5 into 62 upon 5. 5 get cancelled. Then you will get here a root of 62. And this is simplified form. Now next question, question number 9. Rationalize the denominator. First, 3 upon root 5. Second, 1 upon root of 14. Third, 5 upon root 7. Fourth, 6 upon 9 root 3. And fifth, 11 upon root 3. Now, first example, 3 upon root 5. To rationalize the denominator, we have to multiply to the numerator and the denominator by root 5. And hence here, 3 into root 5, root 5 into root 5, you will get here 5. And therefore, 3 root 5 upon 5. And hence, the answer is 3 root 5 upon 5. Now, next example, 1 upon root of 14. Again, multiplied numerator and the denominator by root of 14 to the numerator denominator. 1 into root of 14 is root of 14. And to the denominator, root of 14 into root of 14, you will get here 14. And hence, the answer is root of 14 upon 14. And here, again, the denominator is rationalized. Next, 5 upon root 7. Again, multiplied numerator and the denominator by root 7. Okay, 5 into root 7, you will get here 5 root 7. Root 7 into root 7, you will get 7. And hence, the answer is 5 by 7 root 7. Because root 7 into root 7, you will get here 7. And hence, 5 root 7 upon 7 can be written as 5 by 7 into root 7. Next, 6 upon 9 root 3. And here we will multiply the numerator and the denominator by the irrational number root 3. Okay. Therefore, 6 upon 9 root 3 into root 3 upon root 3. That is 6 into root 3. You will get here 6 root 3. What about the denominator? 9 root 3 into root 3. Root 3 into root 3. You will get here 3. And after simplification, this 6 means what? 2 into 3. This 3 will get cancelled. And then you will get here 2 root 3 upon 9. Okay. Next, 11 upon root 3. Now again multiply numerator and the denominator by root 3. You will get here 11 root 3 and to the denominator root 3 into root 3. Again root 3 into root 3 you will get 3 and hence answer is 11 root 3 upon 3. And in this way we have completed practice set 2.3. Now we will see in the next video. Till then, goodbye.